Yes, we are live now. A question was asked to me by my YouTube subscriber that why we don't get the mode same as the empirical formula and the data of maximum frequency. Actually, we know that in the data handling chapter, to find the mode, there are various methods. We can find the mode by using empirical formula. Also, we can find the mode by just looking at the table and telling the data that is having the highest frequency. But the thing is that by calculating the mode using empirical formula and by looking at the table having the highest frequency, both modes are numerically sometimes not the same. They come different. The question is this only, that why with the empirical formula the mode is coming different from the mode that we see in the table directly. So let us understand this one. First of all, my introduction. My name is Vijayan Sharma and I will discuss on this topic. First of all, let us see the basic concepts. In the data handling chapter, when we talk about the central tendency, we have three kinds of central tendency. That is the mean, median and mode. Mean means average of all the data. Median means middle value, the data that comes in the middle of all the given data. And mode means the data that is having the highest frequency is called the mode. And the data that is given to us can be of two kinds. They can be either group data or they can be either ungrouped data. For the sake of simplicity, in our example in this video, we will discuss mode in a group data, in a grouped frequency distribution table or group data. Now, to calculate mode, there are various methods. One is just the observation method, where we will just directly see the table and see which data is having the highest frequency, and that is the mode. That is called the observation method. Second method is the empirical formula method that we will discuss now. And the third method is graphical method also is there, that is used to find the mode. Now, let us see what is this. First, let us understand the empirical formula for mode. Mode is equal to 3 median minus 2 mean is a formula that is called the empirical formula, and this was given by Carl Pearson at the University Statistics Department at University College of London in the year 1911. This is that great scientist who discovered this formula in his university. This formula gives an exact value of mode. Now, let us take an example. In this given grouped frequency distribution table, we will find the mean, median, mode of this. So this is a grouped frequency distribution table where the groups are made. These are the groups. It is also called range, and this is the frequency of each individual groups. First of all, we will write the range. We will write the frequency of each individual range. Then we will find the cumulative frequency. Cumulative frequency is nothing but the addition of all the frequencies done row wise. Then we will find the class midpoint or class mark, that is denoted by using xi, where the formula is upper limit plus the lower limit divided by 2. So we can see 10 plus 0 divided by 2 is 5. 20 plus 10 divided by 2 is 15. Like this and so on. We have completed the table. The fifth column is called the Fi into Xi, that is the frequency. This is frequency multiplied with the class midpoint, that is Xi, and that is written over here. The first thing that we will calculate is N, capital N, that is summation of all the frequency. This column, the summation of all the frequency is coming 115. Second thing we will calculate is summation Fi Xi, this column, and it is coming 7855. The first central tendency is the mean. We will calculate the mean here. So we are calculating the mean. Mean is equal to x bar, denoted using x bar, is equal to summation Fi Xi divided by summation Fi. After doing the calculation, we are getting 68.304. This is the mean. To find the median, first we will find out the median class. To find the median class, we will do n by 2, that is 115 by 2. The value is coming 57.5. So any cumulative frequency that is 57.5 or more than 57.5 will be selected as the median class. So we can see that 58 is exist. So this is my median class. After getting the median class, we will find the median of this table. To find the median, we will use this formula L plus n by 2 minus Cf divided by Fi into H, where L is the lower limit of the median class, Cf is the cumulative frequency of the class preceding the median class, and Fi is the frequency of the median class. And Fi is the frequency of the median class. So putting all the values, we are getting 69.782, that is the median. 69.782 is the median. Now, after getting the mean and median, we will now calculate the mode. To find the mode, we can directly look into the table and see which is having the highest frequency. Obviously, we can see that 29 is the highest frequency, and the data corresponding to 29 is 75. So we can easily say that the mode of my table is 75. Now, again we can calculate mode from the empirical formula, that is 3 median minus 2 mean. By putting these values of median and mean, we are getting 72.738. So this is also one mode, and that is also one mode, 75. So we are getting two different values of mode. And this is the question asked to me, that why the empirical formula gives you the mode that is different from the mode that we see in the table directly. This is the question asked in the doubt, that why the two different kind of modes exist. So let us discuss about this. This particular table that you are seeing, we will plot this table in the form of histogram on the graph paper, and this will look like this. This is the histogram plot of that given data. 0 to 10, 10 to 20, 20 to 30, all these kinds of class interval is given. So this is the plot of the given table in the histogram form. Now 29 is the highest frequency because it is having the highest bar in the histogram, that is the highest frequency. So one bar previous to this bar is this 23. So from this point if you draw one line to the corner point here, and from this corner if you draw one line like this to this point, the point where these two lines intersect, from there if you drop one perpendicular to the x-axis, it is corresponding to a value on the x-axis. Now what is this value? This value is also same as 72.738, that is the empirical mode, same as that of the empirical mode, 72.738. It was calculated using this formula. That means graphically also and empirically also, both the mode is coming 72.738. But the question is, from where that 75 is coming? That is also one of the mode from the table, as we can see. So how the two things are different? If we zoom this part and look at this carefully, I have zoomed that part and looking at it carefully. This point is the 72.738 and this point is my 75. You can see that there is a little bit difference between the 2 points. The question is why these two difference exist, why the two different values of mode is there. Now let me explain you. 72.738 is the actual value of the mode, calculated graphically and empirically, both giving the same. And 75 is nothing but the class midpoint or the class mark. 75 was taken as the class midpoint or the class mark to represent the class between 70 to 80. Just as 55 represents the class between 50 to 60, 65 represents the class between 60 to 70. Similarly, 75 represents the class between 70 to 80. So 75 is the class midpoint that was calculated using this formula, upper limit plus lower limit divided by h, that is the class height. This 75 is not the mode. 72.738 is the mode, empirically and graphically both. So the thing is, why do we consider 75 as also the mode? Actually, you see, the correct answer of the mode is 72.738. This is the correct answer. But when the number of data is small, then the empirical mode and the class midpoint both are different, slightly different. When the number of data is huge means 10 lakh data, 1 crore data, so many number of data is given, then when you find the mode, that time you will see that the class midpoint and the empirical mode both will be numerically approximately the same. Since our data is less, So there you can see the difference between the two kind of mode. But the actual mode is the empirical mode, that is the actual mode, graphically and empirically both, that is proved. 75 is nothing but the class midpoint, and when the number of data is huge, class midpoint and your empirical mode both will coincide and both will be the same, numerically is the same point itself. I hope you understood this one. Thank you.